we looked at word problem under linear equations during our previous meeting. That was last week. So we're going to continue today with linear inequalities. So before we continue with linear inequalities, we will go through some few examples and the word problem that I've given you class assignment, but we'll try some 1 or 2 questions here, then we continue. Yes, I'm ever rejoice. Unmute yourself and ask your question.
Yeah, I'm okay now.
Okay.
I'm okay.
Okay.
Sir, please, I can't hear you.
Then check the network connection at your end. Let's try this question. Okay. Please let's write down this question and try our hands on it. 7 less than a number is
Sir,
3 more than 1/3
please, I
the
can't
number.
hear you.
Seven less than a number is 3 more than 1/3 the number. Find the number. I hope we've all finished writing the question.
No, sir.
Then hurry up. I want you to try your hands on it. Please, let's be fast with it a bit because our time is fast spent. Okay, let's try that within some 5 minutes. Arthur Desmond, unmute yourself and ask your question.
Sir,
Yes, Desmond.
sir,
Yes.
I had the answer. I'm not sure. It's an answer. It's a
11.
question.
Your answer is 11.
Sir, no, 15.
15. Okay, let's wait for the rest. Yes, Ada perfect.
I also had 15.
Let's add 15. Okay.
Sir,
Yes. No.
sir,
Yes.
uh,
What's an Enoch?
15.
Okay.
So I had 15.
All right. Yes, Wahid.
Sir, 15.
Okay. Now let's compare the answers and see what you've done so far. Yes, Savannah to 4. Savannah, talk. I'm listening to you.
15.
Okay, thank you. So this is how we should start. We let the number be a variable. So I'm using my variable to be A. Let the number be A. That is me, my number. You can let any variable of your choice to be the number. Then we start forming the equation 7 less than a number. We form that equation down. 7 less than a number implies the number minus 7. Then we take the other condition, 3 more than 1/3 the number. So we first of all have to find 1/3 the number. That will give us 1/3a. Then 3 more than 1/3 the number is 1/3a plus 3. Now we consider the whole equation. 7 less than a number is 3 more than 1/3 the number. So you have 7 less than a number and you have 3 more than 1/3 the number already. So we just equate them. That will give us a minus 7 is equal to 1/3a plus 3. Dividing through by the LCM of the denominators, we're going to get 3 times a minus 3 times 7 is equal to 3 times 1/3a plus 3 times 3. Now when we simplify, this is the result we're going to get. 3a minus 21 is equal to a plus 9. Then when we group like terms, we're going to get 3a minus a is equal to 9 plus 21. Then we get 2a plus, sorry, it should be 2a is equal to 30. Yes, are they perfect?
Say, can you just like group like them, and then you do this one? You bring the 1/3 x and then you subtract it from the x and get 2x/3 equals to 10. Then you divide through by the 2/3x.
Please come again.
So you group like terms.
Okay, so you
You
have,
bring the 1/3 x.
okay,
You bring the 1/3 x to the x, then you subtract and get
okay,
2/3x
okay.
equals to 10. Then you divide by the 2/3.
It's very correct.
Okay, sir.
Yes, but sometimes to make your work very simple, you can still divide by the denominators first. But if you want to use the fractions to be correct, that means you have to be extra careful. Okay. Then we have 2a divided by 2 equals 30 divided by 2. When we divide both sides by 2, then our a is equal to 15. So the number there is 15. Please, any question? Any problem about this? Okay, let's proceed from there. Linear inequalities. You are going to look at inequalities. Let's look at some of the symbols of inequality. When we talk about inequality, that means the things are not equal. They are unequal, inequalities. They are not equal. There's a relative difference between two terms. So that's what we mean by the inequalities. So let's look at some symbols of inequalities. When symbols such as less than or equal to, greater than or equal to, less than, greater than, and not equal to are used in an expression, such statements are referred to as inequalities. So let's look at some scenarios. When we have A, x less or equal to y, it implies x is less than or equal to y. For the first symbol, less or equal to, that means x is less than or equal to y. So when x is less than y, that means they are not equal. So this inequality sign here is telling us that the two terms, the relation between them, that they are not equal. That's the relation between them. The B, when you have x greater or equal to y, implies x is greater than or equal to y. That means that x is a number which is greater than the number y or equal to. So they are relative numbers. And from x, when we pick it from where it is equal to y and above, the rest of the numbers should be greater than y, which will also represent a number. Then when we come to the C, x less than y implies x is less than y. That means there's a number of x which is less than a number y. So there might be so many numbers that will be less than the y. For instance, when y is 2, that means x will take a certain range of numbers. So any number that is less than 2, if y is 2, any number less than 2 is for y. So for instance, 1, 0, -1, -2, up to negative infinity, they are all numbers less than y. Yes, Jamesi?
Sir,
Yes.
you are speaking, we can hear you, but please, can you raise your voice a little bit more?
Okay, no problem.
So we can hear you
Okay,
clearly.
okay.
Please. Thank you.
So, okay, I've heard you. I'll work on that. So what I'm saying is, when we have x less than y, for instance, when y is equal to 2 and x is less than y, that means any number that is less than y satisfies to be x. So when we have 2 for y, 1 is less than y, 0 is less than y, -1 is less than y. They are all numbers which is less than 2. So all these numbers being less than 2 satisfy to be for x. So any number that is less than 2 and 2 is y, then that number is x. So any number at all can be less than 2. That is within the range from +1 to negative infinity. Any number within that particular range satisfied to be for x. When we come down to the D, x greater than y, x is greater than y. You could see that when we take y, or for instance, let's take x to be any number. So let's say x is 5. So when x is 5, that means y can take any number from 4 to negative infinity, because we are saying that x is greater than y. So when you position y as a number to be 5, sorry, x to be 5, then y is either 4, 3, 2, 1, 0, -1, up to negative infinity. Let's look at it from the other side as well. When we take y to be, say, 3, if y is 3, then when we say x is greater than y, that means 4, 5, 6 up to positive infinity, and the value is supposed to be for x. So you can position a value at a certain variable where we have the two relations. Then it depends how we define the other one. When I'm taking the x in the example D, and I want to position it at a variable, at a value, let's say x is equal to 2, then y must take a range of values that must be less than 2, because x is greater than y. So that means the 2 must be greater than any number that y will take. So when my x is 2, then y must be from 1 to negative infinity. All the negative numbers, including 1, they're all numbers less than 2. And if I position the number at y, and for instance, I say my y is 2, that means all numbers greater than 2 are for x. So 3 is greater than 2, 4 is greater than 2, 5 is greater than 2, up to positive infinity. So in this case, any number greater than 2, and 2 is for y, supposed to be for x. So we pick it from positive 3 up to positive infinity. They are values that are greater than 2. That means x is greater than y, and we are defining our y to be 2. So it depends how you define the variable in respect to the value you are giving to it. Let's go to the E. X is not equal to y. We are saying that x is not equal to y. So if x is 2 and y is negative 2, they are not equal. If x is 1 and y is 2, they are not equal. If x is 2 and y is 2.1, they are not equal, because 2 and 2.1, they are not the same value. So x is not equal to 1. That means there's a difference. Okay. Let's go to the F. Negative x less or equal to negative b. Already, we have definitions for the inequalities already. Now, there are cases where the inequalities will change. The instance where the inequalities change is when we have a negative number multiplying through or dividing through. For instance, negative x is less than or equal to negative b. So when we multiply through by -1 or divide through by -1 to make the one at the left-hand side positive, the coefficient of x to be positive, then the inequality sign must change to greater than or equal to. And when we have negative x greater than or equal to negative b, and I divide through by -1 or multiply through by -1, then my inequality sign also must change to less than or equal to. G, if I have my inequality equation to be negative x less than or equal to b, it implies x is greater than or equal to b. Let's start this example. We are saying that negative x is less than or equal to b. So let's take a value for x and a value for b. When x is negative, let's say x is 2 and b is 1. If x is 2, the negative x is going to be -2. And you know, negative 2 is less than 1. Indeed. Negative 2 is less than 1. Now, when negative 2 is less than 1, and I multiply through the equation by negative number, you could say that the negative 2 will now be positive 2, and the 1 will now be negative 1. So my 2 is greater than negative 1. That is why we have, when we multiply through by negative or divide through by negative, you're going to get the equation to change. So here, x is greater than or equal to negative b. Because when you use the 2 and the 1, x is for 2. So negative x is negative 2. We are substituting 2 for x and 1 for b. So negative x, when we substitute 2 for x, we're going to get negative 2. And b is 1. So negative 2 is less than 1. Then, when we multiply through by negative 1 or divide through by negative 1, we're going to get a negative 2 to be positive 2 now. And then positive 1 will now be negative 1. And you know, positive 2 is not less than negative 1. It is greater than. So once we divide through by negative number or multiply through by negative number, then our inequality sign must change. That is when it involves greater than or equal, greater than or less than. So we have x to be greater or equal to minus b. Good. Then when we have negative x greater than or equal to b, it implies my x will be less than or equal to minus b. Please, any question? If you have any question, raise up your hand and ask. Okay, let's proceed. Considering the points in the above, when both sides of the inequality are multiplied or divided by a negative number, the inequality sign is reversed. So these are some of the examples. 9 is greater than 6. When I multiply through by negative number or divide through by negative number, I'm going to get minus 9 is less than negative 6. And indeed, negative 9 is less than negative 6. Multiply through by negative number again, 9 is greater than 6. And it's true, 9 is greater than 6. And negative 9 is less than negative 6. Let's look at the b. Negative y is greater than or equal to negative 5. So when we use numbers to check this very well, if my y is, let's say my y is negative 2. Yes. If my y is negative 2, then minus 2 will be positive 2. That is, if my y is negative 2, then minus 2. Because y is negative 2, and we have negative y. So it's be negative 2. The y is negative 2. So negative 2 will give us positive 2. Then it's greater than negative 5. So indeed, 2 is greater than negative 5. So you could see that when we multiply through by negative 1 or multiply through by positive 1, I'm going to get the -2 now, I'm going to get y is equal to +5. And we say that our y is what? -2. So if y is -2, the -2 is indeed less than 5. So we have -2 less than 5 because we are defining our y to be -2. Yes, Sam, Gloria, unmute yourself and ask. Sam, Gloria, unmute yourself. You are still in mute mode. So when you talk, I can't hear. Sam, Gloria, please, you don't unmute yourself. So I can't hear anything at all. Okay. Now talk. Sam, Gloria, I can't hear you at all. Your voice is very low. Sam, Gloria, I'm listening, but I can hear some noise at the background. Let's continue. C, -3x less than 15. -3x is less than 15. Then you could see that when we divide through by -3, our sign will change. X is greater than -5. X is greater than -5. So in this case, when we substitute so when we divide through by negative number, you could see that all our sign here will change. And we are saying x is what? Greater than -5. It doesn't mean that x is equal to -5. No. So you can substitute -5 into the inequality. Any number for x, that we are saying x is what? Greater than -5. So any number greater than -5 is what you're supposed to substitute. So all numbers greater than -5, that means -5 is less than all numbers of x. So from -4 to positive infinity, they are all numbers greater than -5. They are all numbers greater than -5. So you can start substituting them into the inequality to see if indeed they are less than the 15. So when we take it from that point, -4 is greater than -5 because x is greater than -5. So we can take -4 to be x. So when we substitute into the inequality, -3 times -4 is +12. And indeed, +12 is less than 15. Again, -3 is a number which is greater than -5. So x greater than -5, -3 is satisfied to be for that value. So when we substitute -3 for x into the inequality, -3x is less than 15, we're going to get -3 times -3, which will give us +9. And when we compare with the inequality, we have 9 less than 15. And indeed, 9 is less than 15. You can keep on testing to verify or look back to see if the problem you are solving has indeed been solved. So we have x to be greater than -5. Any question with the third example? Any question? All right. Yes, Shiva, unmute yourself and ask your question. Shiva, I can't hear you at all. Unmute yourself, please. Yes, Grace, ask your question.
Sir, please, can you use a positive number?
Can you use positive number for
The x is greater than -5.
okay, please get it right from here. You see, we are saying that -3x is less than 15, okay? So after solving, what we have is what we have to use. You can use positive number, yes, because positive number is still greater than -5, isn't it? So it will still work when you use positive number. For instance, let me use 10. -3 times 10 will give me -30. And -30 is less than 15. When I use positive 5, it's a positive number. So -3 times 5, that will give me -15. And -15 is less than 15. So you can use positive number. You can use any number within the range. When we talk about range, range means when we have a boundary. Because the x here is giving us a boundary, the inequality is giving us a boundary that this is where the number must start from, and this is where it must end. So the boundary here, x is greater than -5. It has a limit. So x must be from -4. Any number any number greater than -5 is the value for x, because x is greater than -5. So all numbers greater than -5 are for x, and -4 to positive numbers, all positive numbers, from -4 to all positive numbers are the numbers that are greater than -5. So you can use any of them to test. So it's true, you can use positive numbers. You are there. Yes, any further question? All right. Let's continue. We're going to consider some steps that we need to follow when we are solving an inequality question. So, step 1, if you have inequality, check first if there's a mixed fraction. So, the first thing you need to do is to change the mixed fraction to improper fraction. So, you say consider the following step in solving an inequality. I change every mixed fraction to improper fraction if there is any. So if there's any mixed fraction, that is the first thing you have to do. Change the mixed fraction to improper fraction. Step 2, if there are fractions multiplied through the inequality by the LCM of the denominators. The denominators we're talking about are the numbers that are the down of the fractions. You know, if I have 3, it has a denominator. 3 as a whole number. Let's say I have 3x. Who can tell me the denominator for that? Attaque. Unmute yourself and tell me the denominator for 3 or for 3x as a whole number. Attaque. What is the denominator for 3x? Attaque. Cordial Grace. Please. I saw someone's Cordial Grace. What is the denominator for 3x? Okay. Benedicta Sayram, appear. And meet yourself and tell us the denominator for 3x. Oops. We lost Benedicta too. Okay, Justin. Jamesi Justin. Okay, I'm ever rejoice. I can see your hand up. I'm ever rejoice. Meet yourself. What's in Enoch? Yes, Enoch. Enoch, I can't hear you. Enoch.
1.
Yes. It is 1.
Sir,
Yes.
please, you prevented us from unmuting ourselves, so we
Eh,
couldn't
sir.
answer any question.
Prevented us
Oh,
from.
sorry for that.
Exactly.
Okay.
Don't worry.
You prevented us from our meeting.
Okay. So the denominator for any whole number is 1. So please bear in mind, every whole number has a denominator of 1. Every whole number is a fraction. 2 is a fraction. That's 2 over 1. 2 over 1 is 2. That's 2 divided by 1 is 2. Yes, what's the Enoch? I can see your hand up.
Say sorry, it was a mistake.
Okay. 3. If there are brackets, expand to remove the brackets. That is the third step we need to consider. If there are brackets, we need to expand to remove the brackets first. 4. Group all terms. Yes, Dzidzor, IV. Dzidzor, IV, ask your question and mute yourself.
Sir, please, I can't hear you.
Okay. So the fourth one is a group all terms containing unknown variables on the left hand side. Group all terms containing unknown variables on the left hand side. That is LHS. of the inequality
I'm sure they are all
and
there.
constant terms on right hand side. So what we're talking about is if we have unknown variables containing, let's say, x or a, all terms containing a should be grouped to left hand side of the inequality or the equation. Then all the constants, that is the numbers without the variable, should be grouped to the right hand side of the inequality. That is what we meant by group all terms containing unknown variables on the LHS, that is left hand side. Then all the constants to the right hand side, RHS. 5. Simplify both sides of the inequality. After grouping the like terms, you simplify. First, I'm going to have 3a minus 2a is greater than 5 minus 3. Then to simplify, 3a minus 2a is a. Greater than 5 minus 2 give us 3. So we're going to get a is greater than 3. That is what we meant by simplify both sides of the inequality.
Sir,
Yes.
I can't hear you.
Then maybe it's a network. I hope the rest can hear me very well.
Possible. You can leave and
Or maybe you don't join in with audio.
You can leave and rejoin. No, leave, yeah. Rejoin,
Point 5. Divide through the inequality by coefficient of x, if there's any. You need to divide through by coefficient of x if there's any. That should be our final step. Because we want to make x to have coefficient of +1. Anything have inequality or anything you have equation, the variable must have coefficient of +1.
in the group.
Yeah, we are leaving.
Let's consider the following inequalities. The first one, we have 2 whole number 1/3 plus 5/6x less than 4. So the first thing we need to do is we have mixed fraction there. So we have to change the mixed fraction to improper fraction. Can someone tell me what an improper fraction is? Dzidzor IV. Please, what is an improper fraction? Dzidzor IV. What is an improper fraction? This is with lost IV. Dieudonné Fiati. What is an improper fraction? Dieudonné Fiati, what is an improper fraction?
Their fractions, where their denominators are higher than the denominator.
I can't hear you good. Daniel, improper fraction. Okay. Rebel perpetual. Perpetual.
Please, there are fractions whereby the numerator is greater than the denominator.
Okay, thank you. So improper fractions are fractions that we have the numerator to be greater than the denominator. For instance, 2/5 is an improper fraction. So anytime you change mixed fraction to a fraction form, we are going to get an improper fraction. Okay. So when you change the mixed fraction to improper fraction, you're going to get 7/3. That is the improper fraction after changing the mixed fraction. We're going to get 7/3 plus 5/6x less than 4. Then from here, what do we need to do? Yes, Sylvester Dogbedo. What is our next step?
I can't hear you.
I said after changing the improper fraction, the mixed fraction to improper fraction, what is our next step? Sylvester Dogbedo. Atta Desmond.
Sir,
What do you do next?
Sir,
find the LCM.
so we divide it by the LCM.
Okay, good. So we need to divide through by the LCM. That will give us, sorry, we multiply through by LCM. Not divide through, we multiply through by LCM. And our LCM is 6. So we multiply through everything by the least common multiple. So it will give us 6 times 7/3 plus 6 times 5/6x less than 6 times 4. Then we're going to get, when we simplify, we're going to get 2 times 7 plus 5x less than 24. Then, when we simplify further, we have 14 plus 5x less than 24. When we simplify further, we need to duplicate them from here. Our constants to one side, and the ones without constant also to one side. So we have 5x. So we have 5x is less than 24 minus 14. Then we simplify, which will give us 5x less than 20.
10.
Oops.
Sir, it's supposed to be 10.
Sir, it's supposed to be 10.
Yes, sorry, it's supposed to be 10.
It's
Sorry.
supposed to be 10.
So correct that. 5x is less than 10. So x must be 2.
Attacking now you talk.
X must be 2.
Sir,
Yes.
please, is that how we are supposed to conclude? Or there is another way?
Oh, that's all. X is less than 2.
Okay.
B, find the truth set of 2 minus 1/3 into bracket 2x minus 1 greater than 2/3x. So let's try this. Please hurry up and write the question and let's try. I hope we all got the question.
No, sir.
Okay.
No.
No.
Okay, that's the question. Please just try, copy just the question. I want you to try your own and follow the steps for your own understanding. If you have any problem, I will take you through. So copy just the question.